This is page 20, question 11. Page 20, number 11, and this is the mosquito question. It's probably the most advanced question on the page. And once again, like number 12, we'll start off with a sketch. And in this question, you've got a mosquito that's coming towards you. The mosquito is 35 meters away from you, and at some point the mosquito is going to hit you. Gives the mosquito's velocity is 2.4 kilometers per hour, which is 0.667, or 66 repeating, meters per second. And your velocity is 2 meters per second. Okay, so mosquitoes go much slower than you. And if we're drawing a sketch of this, we're going to say that you are moving in the positive direction. So you start at the origin and you go like so. The mosquito is coming towards you, going at a slower velocity, and he's 35 meters away. So this is what the graph for this problem is going to look like. And this is 35 meters at this point. Oh, this is a distance time graph. And we are, again, trying to find out the time and the displacement when you and the mosquito collided. So there's your sketch. Once you've got your sketch, it's going to give you a lot of clues to solving this problem. So it's really important that you do a sketch for all of these problems. And then we're going to do the same way that we did number 12, number 12. With the DVT graph, we have you, we have the mosquito, and you just have to be very careful about the signs in this one, positives and negatives. Because for you, your velocity is 2 meters per second, so that's pretty obvious too. The mosquito's velocity is also obvious, 0.067, but you have to acknowledge the mosquito is that you're going in opposite directions. So one of you has to be negative. We'll call it the mosquito is negative. And then let's look at the displacements. We have no information for time. We don't have any specific values for this displacement right here, but we do have some clues. We do know that the mosquito is going to travel this distance, and you are going to travel, I'll do it in with a purple, you are going to travel this distance. So at least we can write expressions for the distances that you and the mosquito have traveled respectively. So let's call, what shall we call what? Let's call you X. And you could call the mosquito X if you want. You could call the whole thing from 0 to 30. Oh, no, you won't want to do it that way because that would be a little trickier. But let's call you X. So you are going to travel a distance or displacement of X. What's an expression for the mosquito? Well, the mosquito starts here and travels just the black bracket there. And what's an expression for that? Well, that's going to be 35 minus X. 35 minus X will give you this displacement right in here. But once again, you have to be very careful here. You have to acknowledge that the mosquito is going in the opposite direction that you are going, so therefore it's negative. And once you've got this information, you can proceed in the same way that we did question 12. In other words, you can now write an expression for time. We know that time equals the distance over velocity, or displacement over velocity, and therefore an expression for the time that you are traveling is going to be X over 2, and an expression for the time that the mosquito is traveling is negative 35 minus X over negative 0.667. Okay, now at this point you're probably saying, well, geez, don't those two negatives cancel out? So it would have been kind of irrelevant if I put the negatives in. It would have been if you only put the negative in for one of them, then you would have had a problem. But it's very important that you put those negatives in there to indicate that the directions and the velocities are different. And at this point, we know that both you and the mosquito are traveling for the equal amount of time, the same amount of time, and so you can simply equate those two values. The time that I'm traveling equals the time that the mosquito is traveling, and you've got a single variable equation solved for x. So the first thing we're going to do is just eliminate those negatives, pretend they don't exist, because the negative divided by negative is positive. And then we're going to cross multiply. That's going to give us 0. Oops, that's not very legible. 0.667x equals 2 times 35 minus x. Distribute 0.667x equals 70 minus 2x. Move the 2x over to this side by subtract or adding 2x to both sides. And that's going to give you 2.667x equals 70. Divide both sides by 2.667 divided by 2.667, and you get an answer of, I don't have my calculator here, so I'm just going to call up the calculator on my computer. 70 divided by 2.667 equals 26.2. So there's your answer for x. X is 26.2. Now don't jump to any conclusions here. Make sure you go back to your table so that you know what x is. There it is, right there. X is the displacement, is your displacement. So you will have traveled 26.2 meters, which kind of makes sense according to that diagram. The mosquito is going to have traveled 35 minus 26.2, which is, what is that, 8.8 in the negative direction. And the time is going to be 13. You're going to put the 26.2 in here, 13.2. So when will you meet? You will meet in 13.1 rather, sorry, 13.1 seconds you will meet, and your displacement will be 26.2 meters, and the mosquitoes will be 8. Was it 8.8? Did we say 8.8? What was it? 35? Yeah, 8.8 meters. Okay, so I hope that clarifies things for question 11 on page 20. Again, the difficulty of the problem is the directions. Make sure you get the directions right. Make sure you do a good sketch, and you should have no problems.